Now let's look at question 1c. We don't have to do 1b, this is an inequality one, and that's not in the course anymore. So this time it's indices, so think about how that's going to work out, and we're looking for a divisibility one. Slight change in this one, although it's integers, it's n is greater than or equal to 0. So this time our first term is not, although it's still p1 as our first term, we're actually looking for the 0 value for n. So, like before, we replace n with 0. So being a little bit careful, because 3 to the 0 is 1. This gives us 4, and therefore it's 5, which we know is divisible by 5. Like always, we assume pk is true. We chuck k in for n and get this equation. And a way of saying that it's divisible by 5 is to write 5a, which means it's divisible by 5. And this may be useful in this form to use, or maybe it will be useful in this form. Remember that indices law says if it's a plus, you make it the same base number and times 2 to the k times 2 squared. That one stays. That may be useful to write 2 squared as 4. Let's see. Now we have to prove that pk plus 1 is divisible by 5. Here we go, k plus 1. Chuck it in for n. That's the first part, there's the second part. Simplifies to give us this. And we know that when there is a plus, we're going to use the indices law. So we're going to break it apart into these two parts and these two parts. 2 cubed becomes 8. Let's see if that helps us. And we also have 27, because 3 times 3 times 3 is 27, and still to the power of 3k. Now you know that we're trying to use pk. We always have to use pk in our proof. So can we force this into here? Well, this is very similar. This is 4 lots of 2k, 2 to the k. This is 8 lots of 2 to the k. So really, that is the same as saying 2 times 4, 2 to the k. And that bit there becomes the bit we want just here. So, the 2 comes down and is there. And we're going to write the 4 times the 2k in here. And in fact, we're going to write the whole thing in here. We keep this out here, but we get a byproduct. If you think about it, when we expand this back out, we're going to get 2 times 4, which will give us the 8 to the 2k. We'll also get 2 times 3 to the k. We don't want that. So I've wrote in here minus the same thing, 2 times 3 to the k. So this one gives us plus, this one gives us minus. When we blend these two together, it's 25. This we already know is divisible by 5. We're assuming that's true, so we can write that as this. And we know that 25 is divisible by 5. It's a multiple of 5. It's a nicer way of writing it, and then we finish off by saying it's divisible. Oops, I missed that bit out. We see down here, there's our multiples of 5, and we can say it's divisible by 5. I hope that helps. Thanks for watching.